Now I'm going to switch to table 2. Just save it, please, guys. Save it, because otherwise it might be a little complicated. Okay, now let's switch to table 2. So let me ask you a question from table 1. What was the weight of Apple and Bank of America in table 1? What was the weight of individual stocks in my portfolio?
50.
50-50, okay? So in table 2, I changed, so I'm going to try with different weights, okay? So the formula is already entered here, so you don't do anything. Just drag and drop this thing, okay? Just drag this thing and drop. So this shows you, if you have a portfolio with 100 Apple and then 0 Bank of America, this will be your portfolio standard deviation, okay, 8 point something. This will be a portfolio standard deviation if it is 90 to 10, etc., etc. This is the one I already had, okay, 50-50. So this is the one I already had here. Maybe I should highlight it with something like, I don't know, greenish. Okay, do you see that? Is this the same as this number?
Yes.
Now select these 2 columns, portfolio standard deviation, portfolio return, insert line chart. No, just delete it. It's ugly. I'm sorry. Just delete it. Just scroll down, scroll down, scroll down. Just give me a second. I think I should do it on my own. I'm sorry. Just give me a second. First, make sure that you get the same numbers. Did you?
Yep.
Oh, okay. I found a mistake. I'm sorry. Can you please hit this cell, which is K7? So this, when you hit the K7, this H7 must have been fixed with F4. I'm sorry, so I forgot to do it. Now drag and drop that thing once again. I'm sorry, that's not even still right. No, it's not H7, it's D25. I'm sorry, once again, you might have been lost, but I repeat. So I made a little mistake. Well, it's Excel's kind of mistake. So hit this cell K7, portfolio return, okay. Hit this D25, and then please fix it, not H7, I'm sorry. E21 and E21 must have been fixed. Okay, and then drag and drop it once again. Okay, so when you scroll down, you should see this graph at the bottom. Let's decrease decimals. Do you see this graph at the end? At the bottom. When you scroll down, do you see this graph?
Yeah, it looks a little different, but it's there.
Or let's do it together. I just delete that graph, fine. Just delete that graph. I highlight these two cells, go to insert and scatter diagram. Do you have the same graph now?
Yep.
Okay, so that's the end of class, but I need to explain, end of meaning that was the whole aim of the class, okay? Now let me explain this. Does everybody have the same graph?
Yes.
Ryan?
Yeah, I'm just following you.
Are you lost somewhere?
No, but I'm just on my iPad, so I'm following you.
Okay, Luis? Okay, who's trying to follow me in Excel?
My chart's a little different, but it's just, I think, one number is off.
Okay, let's delete this graph. Do you have the same numbers here? Do you say, are the numbers same? Is portfolio standard deviation same?
No, it's wrong. But you said do 8, 7, and then D21. You did.
So this one,
Yeah.
This one should be D21. E21 must be fixed here.
Okay. I got it. Yeah, I got the same numbers now.
Okay, now select it. Select these two columns. And then click the scatter and the first one. Guys, the point is, I could have taught you using these like real ugly formulas and then the slides, but you would never understand it. Now I'm just like trying to make sure that you touch it, you experience it, and then hopefully, at the end of the class, you would understand what I'm just trying to teach you, okay? So if you have this graph, right click on the axis, format axis, please. And then change this minimum to 6%, okay, 0.06. Sorry, just the shape of the graph would change a little.
I got it.
Okay, what I'm trying to tell you now, the idea of all of this experience is this. On the x-axis, make the graph a little bit bigger so that I could explain it in a better sense. So on the x-axis, we have, so this x-axis is standard deviation. Okay, so this is standard deviation. This is expected return. Okay, so this point, this exact point, let's just like show it all together. Maybe I should just like clean this thing. Let me just give me a second. So this point is 9.46. Okay, it is this point, 9.46. And it is where Bank of America, it's exactly the Bank of America's standard deviation was what? Okay. Bank of America's standard deviation 9.46. So if you invest heavily all of your stocks in Bank of America, your portfolio standard deviation will exactly be equal to Bank of America's standard deviation. Okay. So once again, so this is, maybe I should just give some names here. So this is A, B, C, D, E, F, G, oh, G is here, G, H, I, J, K, okay? So this is point A, okay, so this is point A, okay? Which means that we invest 100% in Bank of America, okay? So this is 100% Bank of America, 0 Apple, okay? It's 0 Apple, 100% Bank of America, this is point A. This is point B, okay, which means 10% Bank of Apple and 90% in Bank of America. So this is 20/80, this is 30/70, 40-60. This is 50-50, and this is 60-40, etc., etc. And this is 100% Apple, 0% in Bank of America, okay? Which is point K. This is point K. So this is point C, D, E, F, G, H, I, J, K, okay? Does it look ugly? So maybe I should just write this down. These are the points. So this is 100% in Bank of America. This is 100% in Apple, okay? So let's go back to Apple once again. So if Apple's standard deviation was 8.26% with 0.36% mean, okay? So when you go back to your graph, this is 8 point something, which is 8.26 risk. And this was 0.3 something, 20 other. So this is Apple itself. So bottom line is this. Once again, I'm going to erase this. So you have Bank of America here. You have Apple here without these dots. Forget about the other dots. This is Bank of America. This is Apple. So somebody told you, hey, Peter, I have Apple with its standard deviation here, expected return here in the last 5 years. This is Bank of America's standard deviation. This is Bank of America's expected return, okay? So now he's asking you, hey, just like give me some advice, okay? So how should I form my portfolio between those two things, okay? This is Apple, this is Bank of America once again. So it totally depends on the correlation, okay? Now I'm going to change the correlation, okay? Let's go here. I'm going to play with some numbers, so I'm going to scroll down. I'm going to change this correlation to 1, okay? It's not 1, but I'm going to change it to 1, okay? And then take a look at the graph, please. Now it's 1. All numbers changed. So now it is a straight line, okay? So if the correlation between two numbers, two stacks is 1, then depending on the weight, so this is 110, 100, 0, 910, 80, 20. So depending on the weight of your portfolio, any kind of portfolio is going to be between those two dots in a straight line. So this is correlation 1. If the correlation is 1, so your portfolio is somewhere between those two numbers, which is the worst case. But if the correlation is not 1, okay, so let's clean this. So just keep in mind, okay, so keep in mind if the correlation is 1, then it's a straight line. Now I'm going to change it a little now. Point 0.9. Take a look at the graph once again. Now it's a little curve. Do you see that? Do you see that, guys?
Yeah, that makes sense.
Now I'm going to change it to like a little more. Instead of 0.9, I'm going to change it to 0.5. Maybe we should just like carry this graph there. That would be easier. Okay, let's do it all together. So let's play with the correlation. Okay, so please pay attention to correlation. So this is 1. It's a straight line. This is 0.9. It's curved. This is 0.8. More curved. This is 0.5. Okay, a little curved. This was our situation, which was 0.46 something. It's a little curved. Now change it to 0. You see that? It means, okay, what does it mean? I mean, it might be, okay, something good, but I mean, I should explain you. So which means that if you have two stacks, okay, if you have two stacks which have 0 correlation, the Bank of America is here, Apple is here, okay? So you might have this portfolio whose standard deviation is somewhere here, 6.2, which is well below Apple's and Bank of America's. But the expected return must be between those two numbers. No way that you can just get rid of that, okay? Expected return of your portfolio is going to be between those two numbers, but your risk might be lower than individual stacks, okay? So this is your risk. I mean, this is 100, 0, this is 90, this is 80, this is 70, this is 60, this is 50, this is 40. So which means that if the correlation is 0, so if you invest 40% in Bank of America and 60% in Apple, your portfolio is going to be here, whose risk is going to be by far lower than any of those, okay? So let's continue. So let me show you the magic now. Okay, change it to negative something, okay, -2. Okay, so now we have to play with the axis, I'm sorry. So just click on the axis once again, click on the format axis, change this minimum to 0 once again, change back to initials. Okay, now we change it to -2, change it to -0.5, it's even lower, change it to -0.7 or 8, okay, -0.8, and lastly, change it to -1. You see that, guys? So there's a portfolio here. You see this portfolio, this one?
Yep.
Okay, so can somebody explain me what's going on with this red portfolio? What is it? What does it mean? This is a bonus question. What is this point? By the way, I can give you some clues. This is Apple. This is Bank of America. And my question is, what is this red dot?
The lowest risk portfolio that you can build out of these two stocks.
Okay, just like evaluate a little bit more. Under what condition?
I guess, okay, given that those stocks correlate negatively.
Exactly. Okay, so
-1.
Okay, so given that, so this is the bottom line. Given that you have two stocks, assume that Bank of America is here and Apple is here. If they are negatively correlated, these 10 dots are the corresponding portfolios with the corresponding weights, like 100%, 90%, etc., etc. And this red one, okay, this red one is probably, let's say, if this is 100% Bank of America, 90% Bank of America, 80, 70, 60, so this is 50. So 50%, 50%, these are the weights, by the way, the weights. Okay, so if the correlation between Apple and Bank of America is -1, this portfolio would be the lowest risk portfolio, okay? Lowest risk portfolio. So if you invest 50%, 50% Bank of America and Apple, you will get a portfolio of, let's see, whose risk is 0.6%. It's not even 1%. Remember, Apple's risk was 8%. Bank of America's risk was 9-point-something%. So you have a portfolio whose risk is almost 0.6%. Like it's not even half. It's a quarter of, maybe not even quarter. It's 1/10 of any of those individual stocks. So bottom line is this. If you are investing, if you want to invest in two stocks, okay, so if you want to decrease the risk, find two stocks which has the lowest correlation possible, okay? And then it shows you, this example, this whole example shows you that the lower the correlation, the lower the risk of the portfolio. That's the bottom line. Okay, so let's keep it somewhere. And I will show you one last thing before I proceed. By the way, before that, let's come back to this graph once again. So in this graph, so that you just like combine those dots. Okay, so this is Bank of America once again. This is Apple once again. Okay, these points, maybe use different color, green. The upper part of the curve is called efficient frontier. This is called efficient frontier. Efficient frontier. Just because, remember the definition of efficiency in the beginning of the class. Does anybody remember that? Here's another bonus question. What was the efficient frontier? What was the efficiency in this, in finance setting? What was efficiency? When I say efficient, what do I mean? Do you remember that, or take a look at that?
Well, it's the optimal combination between a return, maximum return, and lowest risk, basically.
So given the risk, it should be as high as possible, or given the So just a second.
Because for each point on this green line, you will have another point on the lower line.
Exactly, exactly. Thank you.
They have the same return, but the same risk, but different return.
Okay, that's what exactly I was saying. Thank you. So you got the ones. Okay, so once again, let me show you. So I just like moved it a little bit more. So this is the graph once again. So this is the graph. And look at the green line once again. Green line is called efficient frontier or efficient line, just because look at 4% risk. If the risk is 4%, there's one portfolio here, there's another portfolio here, okay? Say this is the first portfolio, so for the A. Oh, we already gave them a name, right? A, B, C, D, E, F, G, H. Okay, say this is H and this is D. If you compare H and D, they both have the same risk, okay, which is 4%, but D has a higher expected return. So this part of the curve is totally irrelevant, okay? Because for every single point here, there's a corresponding point at the upper part of the graph, which has higher expected return and the same risk. Does that make sense? So every single point on this chart has a corresponding higher return in the upper part of the graph. So that's why we call this green line efficient frontier. This is the efficient part. Efficient frontier. The battery of my iPad is going to die. Are you with me up to here?
Yep. Yes.
Okay, one last thing before we finish. Let's switch to table 3. Oh, I should clean my screen. Okay, guys, I'm pretty sure that you might probably have lost somewhere. Fine, this is being recorded, so you can watch it again and again to get the idea. I'm very sorry, I didn't want to just like use those graphs to explain the things. I mean, I wanted you to kind of touch it, experience it. So they are the same exact thing, and you would realize that. Remember this thing, this line, this is the correlation 1 line, correlation 0 point, and then this is the correlation -1. You see that triangle is -1. So if the correlation is negative, that's the best case, okay? One last thing, again, go back to Excel sheet. Okay, now there's an explanation here. Just do it, please. Select the whole chart, okay? Okay, before I do it, let me explain what this is. So at the upper left of the graph, there's a formula which calculates the standard deviation, which is risk of the portfolio. So the question is, what happens if I change the weight? What happens if I change the correlations? And there's a tool in Excel. If you highlight the whole table here, go to data, and there's the what if analysis here, and then click data table. Are you with me?
Yes.
What
Okay.
did you click again?
Once again, select the whole table, go to data here, and then from data, click what if analysis and data table.
Okay.
So for the raw input cell, there's an explanation here. If you are lost, you can watch it from there. Hit D25. D25, which is the correlation. Column input cell, hit H7. So it should be exactly the same. Do you see my little tiny window here?
Yeah.
Oh, Alejandra, are you there? Did I kill your patience, Alejandra?
What do you say?
Did I kill your patience? Did you able to follow what's going on?
Yeah.
Oh.
I made the tables.
Okay, hit OK. This table is filled. Okay, so what is this graph? This graph shows you the standard deviation of our portfolio. under different correlations and under different weights. Okay, please pay attention to all those numbers and tell me which is the lowest number and what is the case there. Under what condition I have the lowest standard deviation?
Your correlation's -1 and then 50% weight.
That's correct. Yeah.
Money?
Yep.
Okay, right. So okay, the lowest number is here. Okay, maybe I should highlight it. The lowest number is here. Most probably, if you had some more numbers in between, say 51%, whatever, that would be great. But anyhow, under those conditions, so it shows you that the risk of your portfolio is minimum under those two conditions. The first one is you divide your money equally between 50-50 between Bank of America and Apple, and the correlation between those two stocks is -1. Okay, so this is called what if analysis. Okay, what if the correlation is -80? What if the correlation is -60? What if the correlation is 50? So this is the worst case, by the way. I mean, let's remember once again, if the correlation is 1, you can never eliminate risk. So the correlation should be as low as possible. So the correlation should be here. But the weight, it totally depends. I mean, you can never know. Just check the numbers. Okay, you can even write a program to find even the lowest weight. I mean, there might be, it might be 51% or 52%, whatever. So bottom line is this: under these conditions, under a hypothetical scenario, if we keep everything the same, just change the correlation and the weights, I would have the lowest risk portfolio, -1 correlation, and 50, and money is divided equally. So you can keep this Excel sheet. I mean, it is a sheet that I prepared personally. I'm sorry there was a couple of mistakes for that, but anyhow, so if you get the idea, that was it. So let me summarize the whole class in a couple of sentences, maybe. First one is portfolio's return is always equal to this formula. Okay, first weight times first return, second weight times second return. Okay, portfolio's risk is a formula which is very ugly. It's already here, so you do not need to memorize it. But the most important thing about the portfolio's risk, okay, maybe I should just prepare a blank sheet here so that you can at least. Okay, so first thing, portfolio's expected return is equal to first return times first weight, second return, some second weight. Second takeaway is portfolio's standard deviation is equal to a very ugly formula. Okay, it's already there, I'm not going to write it. But it is the lowest when the correlation. So there are kind of different abbreviations for correlation. Some people use rho, Latin, Greek letter rho. Some people use R, but anyways, let me write down. And the correlation is -1. Okay, so this is 2A. 2B, if it is not -1, so the lower, the better. Okay. Third, efficient frontier. So under same risk, we prefer higher expected return. And then this is the graph we prepared today. So if you have one stock here, stock A, and you have another stock here, stock B, the portfolio is somewhere between those two numbers, depending on the correlation. If correlation is 1, this is value of portfolio B, okay? It's correlation 1. The correlation is 0.9, 0.8, 0.7, 0.5, 0.0. If it is -1, it's
everybody, my name is